shit. Okay. It's dead. Done. Every time I'm gonna start something, I need to pull out my charger. Okay. I know. Everybody is saying, what happened to the Gaussian? What the fuck happened to the Gaussian? Guys, no worries. We are doing some Gaussian today. For Gaussian, first of all, I wanna okay. For the Gaussian, I want to code the benchmark. I want to, first of all, okay, benchmark, no. Our optimal welfare, we want to code that. And we want to compare optimal revenue, optimal welfare. Why not benchmark? Because in benchmark, the mean in the benchmark is different from the mean in the optimal revenue. You want to compare optimal welfare, optimal well, okay, yes, good that I mentioned that. Even though if it is like the parameters sigma I, theta I, and these kind of parameters doesn't make sense to compare them. I think it is valuable to compare revenue, generated revenue in benchmark, and optimal revenue, and first best. Well, first best sucks, but for the benchmark, for sure. Let's see. Yeah, I think that's the most important thing. At the end of the day, you want to say how much money we can generate, right? Or how much obedience cost us. It's weird. Do you think here is too big or here is small? I don't like this. I like to have it cut here. Yeah, no. There should be something. And you want to have a shoulder that is just the size of your head. You want to have 3 heads, actually. So let's keep it on benchmark. Let's keep focused. Oh shoot. No, don't die. Don't die! Fuck. It's not charging. Come on, bro. And what happened? Do you have me? All right. So my notes. Let me take a look at my notes from the last time. So we wanna, that's the most important change, right? We wanna, what did we do previously? We don't even have me, okay. What we did was optimal welfare, no, sorry, optimal revenue for different parameters, right? Like 3-4 data sets, different ranges of sigma I theta I, sigma I omega, and we plotted them with respect, our x-axis was either the ratio of t squared sigma theta I squared over s squared sigma omega squared, or the ratio was s mu omega plus t mu theta I, or the x-axis was what was that? The most important one, R. The most important one was R. We also plotted some stuff for N. We actually have all the plots. And based on our last conversation we had meeting a couple of weeks ago, a few weeks ago, we want plots, but not for 4 data sets. We want to keep it 2 data sets. Instead, we want to compare benchmark, not benchmark, sorry. I want to compare welfare, revenue, and Nash equilibrium. That's what we want to do. Why? Because they are all the obedient ones. And then we have welfare max. We can compare it to first best. We can compare benchmark to revenue in form of payment. Revenue optimal welfare mechanism. What is that? Oh, I think it is the welfare mechanism that maximizes revenue among all of them. And empathy is an outside option which types desire. So it's quite simple for now. We wanna do the code for optimal welfare, and we wanna do the code for optimal welfare, and the other one is optimal, base Nash equilibrium, or Nash equilibrium. Let's take a look at the paper. And we have heat advisory here. What is it? It's pretty hot. I don't know if I should go to kickboxing or no. We don't have AC in kickboxing. AC. No air conditioning, not even a fan. We only have one fan that doesn't do anything. Support MIT, please. Alright. zoned out. Damn, it's funny. Okay. Um, yeah, overleaf. Yeah, let's give momentum. Momentum. Ah, fuck. Honestly, if I just stop this session, go get a pair of batteries for this one. It's been a week. I was actually at CVS yesterday. I forgot to buy. Oh my god. So it was 3 weeks ago. Um, yeah, guys, let's give momentum to this project and finish it. What do I want now? I want money. I want power. I want power. Let's open Anaconda. Yeah, we have all the photos, and they are in PDF. Yeah, these are the photos. Do you remember? Payments. For different values of n. What is this? 1, 2, 3, 13, 14, 15. Oh, it is the code. Alright. And it was good that we didn't add them to the paper, to the overleaf, I guess. Or it is maybe better. I mean, I need to share them before our meeting, but adding them to overleaf like 16 photos may not be a good idea. Yeah, this time I generate the files, I share them before the meeting so people can have a time. Elbow, no elbow on the table. Keep your postures. Jupyter Notebook. Dude, I'm getting distracted. So, Python practice, research, exactly, Gaussian, exactly. So we had revenue, we want that, which we have all the data sets. Right, which you have all the data sets, and then should I speak louder? I guess because the AC is on. Like all of these plots, different data sets we had. Where are the numbers? Yes, 11, 12. Perfect. Now we want to open one for welfare. So we had benchmark. We don't want that. And we want to have Nash equilibrium. Perfect. So it's the time for a new project, which is the best code ever. Damn, let's do some coding. Let's say welfare, rev optimal welfare. That's good. And by that it means what is the payment? Welfare, in welfare optimal, we still have some freedom in choosing the constant in the constant of the payment. Therefore, we have to yeah, by the way, I forgot. It was on me. Yeah, this project should have been ahead. But I mean, I was busy with the Amazon and everything. Okay. So let's go to the top of the code and see what is. This is it. Then we are plotting for different values of R. I think even we are not that interested in plotting this stuff based on other parameters than R, maybe mu, but like that ratio, I don't think we are that interested. Or even if we are interested, numpy as np and then nst, mean theta, var theta, mean omega, var omega, f1, n, then we had this cubic and we had the ellipse, cubic cut the ellipse. This will be the same in optimal revenue as well, and then for different values of R. Simple, right? Still, it should not take us a long time. Change its name to welfare rep max rep. Okay. Actually, let's just set it as welfare. And here I say welfare optimal mechanism with largest revenue. Why did I say in here? And maybe I want to actually sell time. I'm not the same guy. I mean, I am the same guy who's getting better every day and learning and thinks about the problem and solves them and takes action. But my skill sets, I'm not the same guy who didn't know what the fuck is a Jupyter notebook. I can choose the type of the cell now. Alright, I've spent some time on lead code. Let's see what's up with the optimal welfare. So still, even in optimal welfare, the payment formula is this, right? We have this condition. The only thing that is slack is constant in the payment. What is this section? These are just common between all of them. Optimal obedient mechanism, we are having the general setup here. PSD stays the same for optimal welfare, optimal revenue. Obedience stays the same, optimal welfare, optimal revenue. So what is different? I don't want to look at my phone. What is different is the objective function and the individual rationality, which causes the payment. So that's the optimization problem. This is pretty similar. We should add another overlay file as well. How is that possible? Okay. Let's go to optimal revenue. Yes. So revenue is the same, just it has these two added minus T sigma AI theta I minus T mu AI, which causes a lot of problem because we have sigma AI theta I in the denominator and pain in the ass in a sense. The 5 variables, and it comes from the, by the way, it comes from the optimal, it comes from individual rationality, the term over sigma I theta I. So when R is negative, we try to anti-correlate, maximally negatively correlated exactly. And if we have space, we add some delta. I don't know if these are, yeah, they are true. They are right, because they are right. This is not, there is no problem with this, because so we had a lot of results about optimal revenue. We changed all of them. After the time, we decided that individual rationality should be redefined for optimal welfare, because individual rationality is not very important to us. I mean, we can have a lot of individual rational mechanisms or auctions, but the payment doesn't show up in the welfare optimal. It actually shows up, right? Just one of the constraints doesn't show up. Because V, does it show up? It doesn't even show up. Okay. And then when R is positive, nothing when R is positive. Oh, okay. Perfect. Let's go and compare what are the, this is welfare, this is revenue. So these are var omega, beta. Do we have cubic and do we have elliptic? For sure we have the ellipse. X is sigma I theta I over T sigma theta I squared, and Y is sigma I omega over S sigma omega squared. So we have the ellipse, and then we have the cubic. I think it's pretty much the same, right? Let's look at the revenue. Okay, I need to talk more because I'm getting distracted. Uh, so we have the formula for sigma I theta I, sigma I omega, sigma theta j. So we have this degree 4 equation that lambda should be a solution to. And if delta is positive, we have this. Then this is the objective function. Okay. Okay, geometric interpretation. Yeah, I was lost. I couldn't find the ellipse and the cubic equation equivalent here. So let's go over the geometric Honestly, I need to confess something. We didn't touch this problem for a while. I am forgetting a lot of stuff. It's so stupid. I need to do it every fucking day. You know, from now on, start of every day with the Gaussian. That's actually how we can break the manipulated time and stack it over each other. So I start my day with Gaussian, then I hit the gym, which is one day. Then I come back from the gym and I do the other one, my thesis and eBay and recommender system. So we broke the manipulated time and stacked it on each other, so we have 2 days. I think for now having 2 days in one day is enough, and then we can, actually it's really better. I could have started it earlier, but yeah, let's try this, because I used to start the day with gym and then go other activities, my work, I think it's actually a good break from Gaussian and jump into what is the other one? My thesis. And then maybe we can go for a lunch, break the manipulated time another time, and watch some coding. Coding, I learned coding, but we want to finish the machine learning for sure with Andrew NG. Am I talking too fast? Damn. Ah, shoot. Ah. Am I talking too fast? These YouTube videos are blessed. Okay. Okay, we have this motherfucker. Geometric interpretation, some intuition about the structure of the welfare optimal mechanism, describing proposition can be gained with the following geometric interpretation of the proof to linear obedience called concept. Let us eliminate the variable sigma I theta j, sigma, okay, and the rest of the constraints, sigma I theta I, sigma I omega, which we like. We don't like sigma I how to get rid of them. Sigma I usually one of the constraints at least is binding, and we can get rid of it. Three-dimensional parametrization of the optimization problem. The objective function is given by this. Crucially, since R is negative, and it is the objective function, we want to maximize, we want to make sigma ij as small as possible. So we want to choose it as small as possible. The only lower bound on sigma ij is from one of the, is it from the first or second PST? Is the second inequality constraint, which is thus necessarily binding at the optimum, as discussed in lemma 3.3. This implies in particular that the action recommendations are maximally anti-correlated condition on theta and omega. Okay, maximally anti-correlated. Yes, because we are bringing it as low as possible. The fact, okay, let's put some fucking energy to this. Yes, I'm tired of this. The fact that the second equality constraint, wait, I cannot type. Can I? Yeah, I can. The fact that the second inequality constraint binds also let us eliminate the variable. Yes, I want to fuck this sigma I theta j, aj, resulting in a two-dimensional, I like two-dimensional optimizational problem in variable sigma I theta I, which is x times sigma theta I squared, sigma I omega, which is y times s sigma omega squared. The first inequality constraint expressed in the term of these two variables describe an ellipse epsilon. First inequality. So ellipse is our first inequality constraint. And we have it again. You could look at this structural result section. Now everything, I'm remembering everything now. I'm on sharp. Okay, where is it? Structural result. So once round F, right? Once round F, round sigma ij is negative, which is the second case, maximally anti-correlated, negatively correlated condition at theta, and we can have this for some delta and some noises are in standard normal random noises, motherfuckers. In both cases, this is the constraint to lie inside the ellipse. So this is our ellipse in, wait a second, how is this our ellipse? So the second constraint becomes an equality, right? This one becomes an equality, and then substituting the value from sigma h. Oh, okay, because he's saying the ellipse is an equality form, but this is the real ellipse. The first inequality is the inequality that we still have to deal with, and but the ellipse formula, yeah, if you want to write it down in an equality form, that's it. And then, so these are the same. Even we have the value of delta. And then, okay, what is it? What is left here? The thing that is left here is that we have our ellipse, we have nu, we have lambda. Nu, we know what the number is, lambda is, so once we are solving the problem, we have two variables, right? At the end of the day, this optimization problem ends up being in two variables, right? Sigma A omega, sigma A theta I, that's it, right? Yeah, but we set sigma A theta Aj as the minimum. I don't know. So lambda is for the first inequality, which can be 0, which can be positive. Nu is always positive because second one is binding. Nu is positive. Oof, guys, give me energy. Sigma J from the first inequality constraint. How can you eliminate from the first one? Oh, we can eliminate sigma Aj based on the second equality from the first quality, inequality, equality. X quality, Y quality, constraints. Okay, this is the ellipse we are facing, right? So yes, exactly. This is the ellipse, sigma I theta I. Well, okay, the center is not obvious yet, but we have it in the structural result. We have it in the structural result part. This is the way I want to talk for this optimal welfare. Okay. Oh, that's it. That's the ellipse. So we have the ellipse. Oh, lambda. Lambda is the missing part, right? Okay, perfect. Once you look at ellipse, you can see that there is no fucking... Look at the lambda. Look at the ellipse equation. There is no lambda here, right? Yes, there is no lambda. And then we have it. Then we also have a lambda to find. Okay. Where does the lambda show up? Which is lambda in optimal revenue shows up in the cubic equation. here it's a degree for equality, and let's see how it is. Let's go, let's give momentum. Using the expression for sigma I omega and sigma I theta I from multiplying by positive constant. What is this positive constant? There has no lambda in it. The previous inequality is equivalent to. This is the ellipse, right? 29. What is 29? We have sigma I theta I based on lambda, and we have sigma I omega based on lambda. How did we have it? How did we have sigma I omega and sigma I theta I based on lambda? Because of the stationarity, right? Lambda so we solve the, we have a system of equation, rho sigma I omega, rho sigma I theta. Well, we have no sigma I theta j. We have, and it gives us this equation. So we have sigma I omega and sigma I theta based on lambda. We have this inequality, and then substituting by the lambda based on the terms we have for sigma I is equivalent to this, which is solely depending on lambda. Perfect, right? So for the optimal welfare, we have one inequality that is only based on lambda. We find lambda, we find sigma I theta I, we find sigma I omega. We have AI, then we have sigma I j, then we have others, which are sigma AI theta j, and which we have sigma AI aj, AI omega, AI theta I, AI theta j. That's it, that's 4 of them. It should be 5, right? AI. Oh, AI squared. Alright. R is negative by assumption. We have F for theory. F for theory that F minus R, which easily implies that left. Rho lambda to infinity. So what is it? Why should it be an equality? I don't know why it should be an equality. Left hand side in 31 is a decreasing function of lambda. So lambda is 0, it's probably not satisfied, to 0, which is less than the right hand side. So there is an R that after that there is a lambda that after the, like lambda at the positive, when lambda is 0, probably the inequality is not satisfied, or it is satisfied. If it is satisfied, all good, lambda 0. If it is not satisfied, we have a lambda 0 and lambda infinity. At infinity, it is satisfied. The inequality is satisfied. At 0, it's not satisfied. There is a positive lambda that we first hit the unique lambda, the equality on computed, or lambda Okay, I see. But what is the lambda? Strong duality holds and this primal maximum. But I don't. Okay, I have a problem here. I forgot how to use this Lagrangian and KKT. I don't know why should the inequality become equality. Like we should choose the lambda that makes it equality. Equality, sorry. Equality. Inequality and equality. Furthermore, in both cases, V is deterministic. Okay, these are I agreeing to finish describing the mechanism, we use the fact that the second inequality is points all the time. Perfect. Let's go over the geometric interpretation as well. For me, the question is that obedience makes us get rid of sigma I squared, sigma I theta j. Perfect. So now we have three variables. And then we know that the second one binds, but if I wanna, but we didn't solve the optimization problem this way. We didn't say, oh, sigma A, AJ comes from that inequality, second inequality. Seems to me we are saying a lambda for the second inequality and nu for the, yes, we are not using this fact here. If you look at it, we say nu is positive, so the second one is binding. So we are assigning a random variable, a Lagrange multiplier to the second one. So we are taking the optimization problem in three variables, not two. Lambda for the first one, nu for the second one, and then we are saying that we have let's go over the geometric. Stationarity for stationarity is planetary. It's planetary. It's planetary. Stationarity is planetary. Stationarity further implies that at the optimum point this lies on a portion of hyperbola parameterized by the non-negative one. Stationarity. What is the stationarity? Stationarity is like around the Lagrangian around sigma aj's. Okay. implies that the optimum point at the optimum, the point this, on a portion of hyperbola parameterized by the non-negative. What is this hyperbola? Oh, okay. 23. So sigma, they are which one was hyperbola? 1 over x is y. Yes, this is hyperbola. Okay. So we have this hyperbola. Okay, perfect. So here we can say we have these two curves based on lambda, right? Hyperbolic functions. And then we also have this, one way is just we can say lambda is the positive root, unique positive root to this equation. Probably we don't want to use it, it's a degree 4 equation, and we don't want to use it. We don't trust the root function in Python or something like that, the reasoning being. So we want to say sigma I theta I and sigma I omega are this hyperbolic function, and they are going to cut the ellipse. Lies within the ellipse, perfect. Outside the ellipse, perfect. These are extra. Yeah, let's implement the code for this. That was let's take a walk. Took an hour. Okay, I'm back. Took us an hour, but I'm back to the game. Yeah, I think we can change the optimal revenue code easily and make the optimal welfare. Yeah, let's finish this paper. It's over. It's done. Yeah, okay, I think better to start it sooner than later because I'm getting distracted again. Okay, let's go, fuck this. Let's wait, fuck waiting for a good mood to start. What is happening? Wait, what was that? What is this? Okay. Now based on R, yeah, we wanna code based on R, import numpy as np, from typing import list, matplotlib import. Okay, these are bullshit. N is 3, S1, T1, min theta is 1, mar theta. Okay, this doesn't matter. M, we need M for finding the lambda probably. We don't want cubic anymore. We want hyperbolic. Right, you want hyperbolic because of these two equations. And what is the input to the hyperbolic exactly? Lambda, similarly R, and float R. Why are we computing mean? Here is far simpler. Do we have mean? We don't have any mean here. So X is sigma, yeah, actually I want to say sigma omega over S times sigma omega squared right. The same for X. Sigma AI theta I. Damn, guys, do you feel that? I just started, now I'm just writing. Don't wait for the fucking mood. Yes, it's just at the beginning it is difficult. Let's go! Momentum, momentum, momentum. Alright. That's it. It's even easier. We don't want to compute any mean or anything. Give it to me. Sorry, here. X sigma I theta I over T sigma theta I squared will be L. Fuck, I should write it down. Let's see. 88%. Perfect. Optimal welfare, we have sigma AI theta I over T sigma theta I squared will be lambda NF times R squared plus 2 F minus R times 1 plus R minus 2 plus R times R over 2 1 plus r lambda in f minus r, fuck you, f minus r minus 1 plus r times r and sigma ai omega over s sigma omega squared is 1 over 2n, and f was 1 over n minus r lambda in f plus 1 over lambda f plus r minus r, right? Where is it? So let's go. X is L times N times F. Wait a second, do you have me or no? Yeah. Is L and F r squared plus 2 times f minus r times 1 plus r and minus, where is the minus? Minus 2 plus r times r that's the denominator over our denominator, which is 2 times 1 plus r and times, this is a big thing. What we do with big things? We make them into small pieces and do it. Lambda times n times f times f minus r minus 1 plus r times r, and let's check it. It is lambda and f r squared plus 2f minus r 1 plus r, perfect. 2f minus 1 plus r, then this one is lambda nf, and then we have minus 2 plus r times r over 2 1 plus r lambda nf f minus r minus 1 plus r times r, then this is perfect. And what is for y? For y it's pretty similar, 1 over 2n lambda nf plus 1 over lambda f minus r. Do dude. That was so easy. 1 over 2n lambda nf plus 1 over lambda f minus r. And then we have the ellipse. Let's check if our ellipse is the same shed. Let's write it down. Sorry. Is that it? Well, we have 2 of them. Which one is it? 1 plus r. How many x do we have? Yeah, we have separate x. So it should be this one, first one. Fuck. Okay. Ellipse. Dude, it was so easy. We just could do it in a second. Your brain thing is big. My brain. Migrate. F minus r over r squared sigma theta I squared times sigma ai theta I minus ft sigma theta I squared over f minus r the whole shed squared plus 1 plus r over r squared sigma theta I squared sigma ai theta I minus t sigma theta I squared over 1 plus r again squared. So 1 plus r squared sigma theta I theta I minus t sigma theta I squared plus r squared plus n sigma ai omega squared over sigma omega squared 1 plus r and less than or equal nf s sigma ai omega plus t sigma ai theta I over fuck off, my brain is talking, f minus r which will end up in this equation, but we have it here, so let me take a look. Ellipse is 1 plus r over r squared sigma theta I bar theta times okay, that's different, f minus r t plus f minus r over r squared var theta times why is it different? The ellipse equation is not affected by our objective function, so I don't know why. Have f minus r to Oh, okay. 1 plus r. I think because we didn't want to have 1 plus r and f minus r in the denominator. That's why we did it. Right? I guess that's the reason. Oh, okay. So let's make it simpler. What we are going to do is we want to multiply the ellipse equation in 1 plus r f minus r, and we will have 1 plus r over, okay, good point, probably the same thing. We will have r squared sigma theta I squared, and we will have f minus r sigma ai theta I minus ft sigma theta I squared. Fuck. So now I have to make sure in the revenue case, okay, we need to check if the epsilon in check revenue. Yeah, alright. Good point. 1 plus r and, okay, fuck, it's really annoying. We need to have different people check the code. So it's 1 plus r squared sigma theta 1 plus f minus r sigma I theta I minus ft sigma theta I squared squared plus f minus r over f minus r over r squared sigma theta I squared 1 plus r sigma I theta I minus t sigma theta I squared plus n sigma ai omega squared over sigma omega squared f minus r less than or equal nf as sigma ai omega plus t sigma ai theta I. Let's check this. So 1 plus r over r squared sigma theta I squared 1 plus okay times f minus r t bar theta x, which is sigma I theta I minus ft sigma theta I squared plus f minus r over r squared var theta squared 1 plus r t var theta x minus t var theta squared minus, where is this minus coming from? Okay, minus, yeah, var omega, yes, plus n f minus r, perfect, over var omega, perfect, times y s var omega the whole shit squared minus NF, uh, NF, right? NF is 1 plus F. Yeah. NF is n over n minus 1. 1 plus F is also n over minus 1 plus F S sigma I omega, which is okay, minus S sigma I omega, which is ys bar omega, minus 1 plus F T. Perfect. Now let's go before forgetting this part. Let's go check the revenue where we compute delta. Where is delta? Exactly. Ellipse is not this. Fuck. Okay. Ellipse is XC Damn, dude, you cannot trust your eyes, you cannot trust your fucking hand, fingers, code. How many fucking times we went over this code? Shit. XC is the ellipse. Okay, this is ellipse. So, the mechanism is randomized condition on theta omega, ellipse constraint E epsilon, which is here, right? It's a slag. In this case, if we denote epsilon, the slag of the positive constraint. Okay, what is the slag? Let's see if this sets the same shit. Same as it is. One plus R. Oh shoot! No, this is. Because this is in the form of the general form. Let's check. It's not very difficult, but it's not very difficult. So don't. So we have this one, which is what we have. Actually, in the code it is not. In the code it is multiplied by 1 plus R F minus. Okay. NF is so he's multiplying it by this. Okay, now we need to be very cautious. And then we have this. Is it this one? 1 plus RT squared sigma theta I squared. Okay. Okay. So we can just fix it by looking at the. That's a good point. We can look at the coefficient of the x squared in the elliptic equation and solve everything. Uh, this paper is such a headache because we have such big equations. And okay, bigger than they are, I made them big in my head. Why is this happening? Start now. You know? Okay, so I want to say x squared coefficient. We are not solving optimal revenue. It's for optimal revenue. Because I am worried if I made a mistake in the code for optimal revenue. Revenue. X squared coefficient. So 1 is the ellipse equation in structural result, which is 1 plus r t squared. And I am just trusting that these equations are right. You know, I'm establishing my code based on the assumption that these are right. If they are wrong, which is possible, we should do all of them again. 1 plus r t squared sigma theta I squared, right? And then for second one, where are we? We want to do it for revenue. All right, so let's look at the revenue. Okay, ellipse doesn't change, so we can look at the welfare. Fuck it. In here, 2 in equation 30 we have it 1 plus r over r squared sigma theta I squared. So if I how is that possible? So it means t squared r squared sigma theta I for oh, once we write it based on x. I see, okay, fuck. That's another problem. Oh my god, fuck you. Okay, x squared coefficient. So, x squared coefficient in theory will be 1 plus r over r squared sigma theta I squared. Sigma I theta I is, let me see, t sigma theta I squared x, which is times t squared sigma theta I to the power of 4, which will be no r, right? 1 plus r t squared theta I squared. We have an r squared here, which I should delete. But how is that possible? Do we have an r squared in the elliptic? Yeah, we have an r squared behind the sigma omega squared, so it's fine. R squared t squared over r squared. And in our code, we have ellipse code we have 1 plus r right over r squared sigma theta I squared plus over I squared sigma theta I squared f minus r squared t squared sigma theta I to the power of 4 plus f minus r over r squared sigma theta I squared 1 plus r squared t squared sigma theta I to the power of 4 that's it, there is nothing else and which is equal to 1 plus r f minus r t squared sigma theta I squared right, 1 plus r f minus r t squared sigma theta r squared over r squared times f minus r plus 1 plus f. This 1 plus f plus r f minus r t squared sigma theta I squared over r squared. So we need to, yeah. Alright, so the delta is not the same delta we plotted before. Ah, fuck! Let's also check. Oh my god, I was sure the revenue code has no problem. Let's also check for equation before 30. What is equation before 30? It is f minus r over r squared f minus r f minus r over r squared sigma theta I squared plus, oh okay, we need to add sigma I theta I. Wait a second, did I add it? It's already. Dude, I cannot trust myself anymore. Fuck, I cannot trust myself. 1 plus r over r squared sigma theta I squared and sigma I theta I, which has t sigma theta I squared which is t squared. And so okay, now here to fucking sigma I theta I will have t squared sigma theta I to the power of 4 plus 1 plus r squared sigma theta I squared t squared sigma theta I to the power of 4, which will be t squared sigma theta I squared f 1 plus f over r squared. So when he says we want to convert equation 21, before 30 to 30, he says what? Multiply it by 1 plus r over nf. Is it true? Nf is 1 plus r over nf will be 1 plus r over nf will be 1 plus r over nf is n over n minus 1, which is 1 plus f, right? 1 plus f is nf, right? So if I multiply this 4 times 4 is 1 plus r over r squared t squared sigma theta I squared. Is it 30? Is it 30? 1 plus r over r squared t squared sigma theta is perfect. Okay, good job. And then we want to see what is the relationship between between 1 and 2, equation 30 and 1, which is the ellipse. You can see that it's just over r squared. And what is the code? It's a bit more complicated. We should multiply 30. We should multiply 30 by 1 plus f minus r, and if we want to have epsilon, epsilon is code times r squared over 1 plus f minus r. Oh my fucking god! Oh my fucking god! I'm dead for today. That's it. Then we will take a break. We will come back with we didn't do anything about the welfare. We just fixed the... And I have to change all... Thanks God we don't need those plots. Delta... Where is delta? Don't tell me that it is already counted. Oh my god. No, that is not true. Xi, okay, yes, we want ellipse, minus ellipse. Xi is minus ellipse, which is code times, where is it? Times r squared times r squared over 1 plus f minus r. Yes, dude, I cannot trust my eyes. 1 plus f minus r. Getting a PhD is not good for your mental health. That's the 1 plus f, or you can say working with big equations. Maybe you can get a PhD with the small equations. 1 plus f r squared times r squared 1 plus f minus r. So if I multiply this code times r squared, r squared multiplied by r squared over 1 plus f over f minus r, I will have 1 plus r t squared. That's it. I'm not checking this code anymore. That's it. I rather publish bullshit. I cannot hit myself every time for fucking stupid model. That brings no value. This fucking model brings no value to my life, to your life. Nobody uses it. Honestly, even if in 100 years somebody used this model, I hope all of their results go to shit, their company burns in fire. That's what I hope. A person should enjoy. Okay, where is the next delta, motherfuckers? Here delta is 0. Where is delta? Oh, dd0, okay. dd delta, right. And we need to check control v. Then xi f minus r squared normal. This doesn't change. This is the same shit here, right? Xi f minus r squared 1 plus r. Delta squared is that, so xi f minus r xi f minus r squared 1 plus r. Exactly 20. Where is it? Delta 0, okay. dd. Why is it 0 again? Delta, that's it. Sorry guys, I'm tired. Is it matched right then? Dude. Math. Yeah, match has T. Okay, match. Match with the okay, perfect. You wanna run this, for example? What? Oh, that was. I think they're good. Yeah, I'm mentally tortured. Enough.